Oh, summer lumber, doomer lumber, you a seaman, I'm a human. What I gotta do to get it through to you, I'm superhuman.
Hey again everyone. I wanted to do this one as a bit of an update to a video I did a long time ago. In that one, I animated stable diffusion generated images by using frame interpolation models and synchronized the lips to the audio in the animation using the Wav2Lip set of models. I'm not going to be using stable diffusion to generate the images for this one though. Rather, I'll be using clipped and interpolated frames from the first Blade Runner film and interpolating them into a longer video that I can then use for lip syncing. For those following along, I'll be using Windows 10 for this, running WSL2 with Ubuntu 20.04 and trying to keep things contained within an Anaconda environment in the Linux distro. First, I'll go over creating and interpolating the clip. Wav2Lip works best on 25 frame per second video, but it seems to be able to cope with anything around 25 to 30 FPS. You can try using anything with a clear depiction of a face, but if you've messed around with any of these ML models, you know it's a bit of a trial and error process. I'm going to be trying to turn about 3 seconds of video into 30 seconds by attempting to cut it into a seamless loop. I talked about Facebook's frame interpolation for large motion model before, and still think it's a good option if you're trying to bridge large gaps in a video. It's a little unwieldy and didn't have any GUI support last I checked, so I think it's best left to its own video. I'll post a link to my old one and try to update it soon. Here I'll be using a user-friendly option called Flowframes, which is a front end for a whole suite of AI interpolation models. Flowframes is open source, with the compiled program released on a pay-as-you-can donationware system through itch.io. Over on itch, the project's front page gives you an idea of what Flowframes can accomplish with a choppy video file. There are 3 sets of interpolation models in Flowframes: RIFE, DAIN, and Flavor. It's a real bucket of buzzwords, but they all accomplish more or less the same goal, and that is to guess what some number of frames are between 2 detected frame images. Head up to the top of the page to find the download link where you can choose to donate to the project or download without donating. I cut up the clip shown earlier in Premiere and exported it as a roughly 30-second video file, then brought it into Flowframes to interpolate. Flowframes and its options are a bit out of the scope of this video, but play around with the output frame rate, multipliers, and fixed frame rate output options on the quick settings menu. Each model can only do certain frame rate multipliers, so be aware of those when selecting the model from the drop-down list. I did runs through each of the models, and the results aren't really compelling enough to warrant going through here. But for the choppy input video that I gave it, it seems that XEVFI did a pretty good job interpolating the frames. That's the video clip for lip syncing out of the way, but what about giving them something to say? For that, I'll be using voice clips generated using the AI voice cloning GUI, which uses Tortoise TTS as its generation backend. Tortoise is slow, but does an incredible job at generating realistic sounding voices, and the AI voice cloning GUI makes it accessible to use and train. I'll link my Tortoise TTS setup, training, and fine-tuning video down in the description, and I'll be doing a follow-up shortly to show a method for generating high-quality voice output much faster using fine-tuned models. To perform the lip syncing, I'm going to be using an offshoot of something I used before, a collection of machine learning models called Wav2Lip, but original repo is quite out of date and has since been archived. A new author has since forked the code and released Wav2Lip-HQ-Updated, which increases the performance and allows for lip syncing larger resolution videos. The old model was limited. I believe it was trained on 192 by 192 pixel faces. This fork also allows you to use CodeFormer or GFP-GAN for face restoration, or use a different trained ESRGAN model for face restoration. I'm going to go through the installation, then I'll do a few runs of the model using the various secondary face restoration models to try to show how they affect the output. Head over to the project's GitHub page and read the installation notes. Scroll down the page and find the download links for the various weights, or find them in the description down below. You'll need the Wav2Lip-GAN checkpoint, the face segmentation model, and any super resolution model you want to try. The project authors recommend the Big Face version 3 set, and have a OneDrive link on the project page with a ton of ESRGAN models. Put the face segmentation model in the face detection SFD directory, and put the other weights in the weights directory after getting the code from the GitHub repository, which we'll go do now. Open up an Ubuntu console and install conda or miniconda if you don't already have it installed. The Wav2Lip code is based on some older libraries that are unsupported in recent Python versions. Create a new conda environment with conda create -n, the environment name, then python equals 3.8 git pip. Activate the conda environment with conda activate and the environment name, then clone the project's GitHub repo with git clone. change to the clone directory and install the project's requirements with pip install-r requirements.txt. You will need a functioning CUDA library installation for this to run effectively. And I'm not going to go over that here because it's generally simply copying and pasting the commands from the NVIDIA site. And that's about it for the installation. To run Wav2Lip, run the inference script with python inference.py and specify the required command line flags for the Wav2Lip checkpoint, the face segmentation model, the super resolution model, the input audio file, the input video file, and the output video file. Optionally, you can swap out the super resolution upscaling for GFP-GAN or codeformer face restoration models. The script will automatically download these weights whenever they're used. I'm going to finish this off by doing a bunch of lip sync runs to try to show how each of the models may perform. However, things may perform better or worse on your own video clips. Each scenario is separate. Although the Wav2Lip model has been trained on larger resolution faces, 1080p full screen faces may not work very well. Here's an example of the model underperforming.
I threw a wish in the well, don't ask me, I'll never tell. I looked to you as it fell, and now you're in my way. I'll trade my soul for the wish, pennies and die for a...
The script has a flag resize factor that will proportionately resize your video. 2 is half resolution, 4 is quarter resolution. Using a reduced resolution may improve performance. Here's the same video re-rendered with a resize factor of 4.
I'll never tell, I looked to you as it fell, and now you're in my way. I'll trade my soul for the wish, pennies and die for a kiss. I wasn't looking for this, but now you're in my way. Your stare was holding, Rip James' skin was showing, hot night wind was blowing. Where you think you're going, baby? Hey, I just met you, and this is crazy. But here's my number, so call me maybe. It's hard to look right at you, baby. But here's my number, so call me maybe.
The sync is much better and the mouth looks quite realistic, however, that's a lot of visual quality to sacrifice. I'm going to try another run with resize factor 2 and see how that comes out. Well, I think that actually looks pretty good. I'll keep the resize factor at 2 and see how some of the other super resolution models affect the look of the face. Here's a run using the Big Face version 3 clear model at resize factor 2.
I threw a wish in the well, don't ask me, I'll never tell. I looked to you as it fell, and now you're in my way. I'll trade my soul for the wish, pennies and die for a kiss. I wasn't looking for this, but now you're in my way. Your stare was holding, Rip James' skin was showing, hot night wind was blowing. Where you think you're going, baby?
And to see how it performs with lower resolutions, I'll run the Big Face clear model with a resize factor 4 as well.
Now you're in my way. I'll trade my soul for the wish, pennies and die for a kiss. I wasn't looking for this, but now you're in my way. Your stare was holding, Rip James' skin was showing, hot night wind was blowing. Where you think you're going, baby?
Well, it doesn't have too many obvious flaws, but it has a grainy look to it, like old standard definition TV broadcasts or VHS tape. Now I'll do a run of the Big Face blend model with a resize factor 2, and see how that looks.
What I gotta do to get it through to you, I'm superhuman, innovative, and I'm made of rubber, so that anything you say is ricocheting off of me and it'll glue you. I'm devastating more than ever demonstrating how to give them up for the audience a feeling like it's levitating, never fading, and I know that haters are forever waiting for the day that they can say I fell off. They'll be celebrating.
It's hard to tell the difference between the clear, base, and blend models with this clip, but clear seems sharper than base and blend. Swapping out the super resolution flag for the enhanced face flag allows you to use GFP-GAN or codeformer for face restoration. Here's a run through the model with resize factor 2 using codeformer.
You will seem that I'm a human. What I gotta do to get it through to you, I'm superhuman, innovative, and I'm made of rubber, so that anything you say is ricocheting off of me and it'll glue you.
The output using codeformer is very crisp or sharp and may give better output with blurrier images with few aberrations. This video is quite sharp already, so codeformer seems to have emphasized that. I'll try a run using GFP-GAN and show how that differs. GFP-GAN will typically sharpen the video less and introduce a little blurring of its own, which may help hide artifacts in the video. I'm going to end things here by showing the GFP-GAN processed video, which is probably the best looking out of the batch. Thanks for watching, and if you like these kinds of videos, please hit subscribe or leave a comment, and a special thank you to the people that have been sharing the videos on Discord and forums. I don't really post or promote them anywhere, so any help getting these weird tutorial videos out there is appreciated.
Well, seeming I'm a human. What I gotta do to get it through to you, I'm superhuman. Innovative, and I'm made of rubber, so that anything you say is ricocheting off of me and it'll glue you. I'm devastating more than ever demonstrating how to give them up for the audience a feeling like it's levitating, never fading, and I know that haters are forever waiting for the day that they can say I fell off. They'll be celebrating